Welcome to topic 4, trigonometry, and lesson 7 of finding unknown angles. So here I've put up a picture of a roof truss, what is on top of the top of your house holding up the roof, and I've said, how do we work out the angle if we know the size of some measurement? So we know the length of those pieces of timber, we want to know an angle in there, particularly in regard to a right angled triangle. So I'm going to use this triangle that I've drawn here. It's a right angle triangle with the lengths marked on each side. And we'll see through this process that to determine an unknown angle, we need to use just two of the lengths in a right angle triangle. So let's start off by marking the angle we want to calculate. And that's shown down there in the bottom left of that triangle by the angle theta. The next step is we need to mark on our triangle each of the sides relative to that angle theta. All right, so the easiest one, of course, to do is the longer side directly opposite the right angle, and that's the hypotenuse, where it's marked number 10, and we've got h for hypotenuse. And back to theta, we see directly opposite theta, our side, the vertical side of length 8, that's our opposite. We mark that in, and then directly alongside theta is obviously the side called adjacent, and that's where we've got, which is 6 long, and or adjacent, or A is marked. Now we're ready to calculate our angle. So let's move on to the next slide to do that. So here we want to start looking at our trigonometric rules. So we've seen this before, and I've just broken them out, the SOHCAHTOA, into each of the three respective rules there for sine, cos, and tan. All right. Now, to find the theta value, we actually need to use an inverse function of sine, cos, or tan. Okay, so we want theta by itself, and we can do this on our calculator. And just to point out, you'll use the second function, that top left grey button on your calculator, second, and then you'll go down and hit sine, cos, or tan, and in that way you'll get the sine to the -1, which means the inverse of sine, or you get cos to the -1, or tan to the -1, which means sine, cos, or tan, the inverse of each of those respectively. All right, so we'll see how that is used in an application for our triangle that we showed just before. Here is our right angle triangle from the earlier slide, and it's got the lengths of the sides 6, 8, and 10. We're going to use the sine relationship first to calculate that unknown angle theta. So I've written down there that sine theta equals opposite over hypotenuse, as we know. Substitute in the values for each of those two sides, simplified it down so sine theta equals 0.8, and now to just have theta on the left by itself, we now write that theta equals the inverse of sine, or sine to the -1, of 0.8. And if we put that in our calculator using the second function that we spoke about, we'll find that theta equals 53.13 degrees. Now we can repeat the same, or a way of working out theta again, but using the cosine relationship. So here I've written the rule as we know it, cos of theta equals adjacent over hypotenuse. I've substituted in the values 6 and 10 for those respective sides. Simplified down, we have cos theta equals 0.6. Now, like we did with sine, we're going to write it as theta equals, this time, the inverse of cos of 0.6. So again, let's use our calculator, and that second function will find that theta equals 53.13 degrees. The angle is the same as we'd expect it to be. We've just simply used a different relationship and used the different side length, but we've achieved the same result. And finally, we could do it with the tangent relationship, which we know to be opposite over adjacent. Again, substituting the values of 8 and 6 for those respective side lengths, we'll work out that tan theta equals 1.333, or 1.3 recurring. Again, we take the inverse of tan like we did with sine and cos, and we'll find that theta equals 53.13 degrees. Again, identical and proving that we've done that calculation correctly. Here's the first of our 3 worked examples, and we have a right angle triangle. We've been asked to find the angle theta. So first thing, I'm just putting down an orange box you might have seen before with the steps listed out that we should follow and our SOHCAHTOA rule to remind us. So the first thing we want to do is label the triangle, and the first one I'm putting in there is the hypotenuse. That is the line, the longest line or side in the triangle sitting directly opposite or across from the right angle. Has a side length of 17. The other side I can mark in is the adjacent. That's because we've been given a length here 12, and it's called the adjacent because it's sitting directly alongside or adjacent to the angle theta. So now we have to decide what trig ratio to use. Well, we've got adjacent and hypotenuse. So we look up here and we see in blue that adjacent and hypotenuse are associated with the cosine rule. So we write down that formula, cosine theta equals adjacent over hypotenuse, and we can substitute in the value for each of adjacent and hypotenuse as we've done there, 12 and 17. Then the next step is that we need to isolate or have by itself the theta on the left. So we can now take the cos and make it inverse on the right. So we now can say that theta equals the inverse of cos, or cos to the -1, of what we have in brackets there, 12 over 17. All right, we could have turned 12 over 17 into a decimal, but I think leaving it like that ensures we get an exact answer. And then we will see through the calculator that we have theta equals 45.10 degrees. So this is the second of our worked examples, and we're going to find theta, correct the 2 decimal places for this triangle drawn in the bottom left-hand corner. So we can see there that we've been given 2 side lengths and the angle theta. So I've drawn the triangle. We want to label them now. The first one we're going to put in is the hypotenuse, and we can see there that directly opposite across from the right angle is the longer side. It's marked 72 as its length, and we've put in hypotenuse or h just to mark that. The other one we can mark in regard to what this angle theta is the side which is opposite. That's the length 49, and we've put in opposite. So now we need to decide what trig ratio we're going to use, and we can see with opposite and hypotenuse, they appear here in red and are associated with the sine rule. So write down the formula, sine theta equals opposite over hypotenuse. We can then substitute in the values for opposite and hypotenuse, 49 and 72 respectively. And then, as we have done before, we want to have the theta by itself on the left, and so we have to take that sine and turn it into an inverse sine, or sine to the -1 of the ratio of those 2 sides, 49 over 72. That can all go into our calculator and find that theta is equal to 42.89 degrees. So our final one here, like example 3, my final triangle here in the bottom left has the angle theta marked, and we want to find out what that angle is to 2 decimal places. So just jotted down our essential, or put down our boxes that we can refer to there, and we have to label the triangle. So the first one that I've labeled in regard to theta is the adjacent. We have a length 12, and that sits adjacent to the angle theta, that side, so I've called that side adjacent. And likewise, the other side I have the side marked with the length 9, it's directly opposite from theta, so I've put opposite there. Note that we don't know the longest side or the side opposite the right angle, so there's nothing we can do about that for the hypotenuse. So step 3 tells us to write down the trig ratio, and here, because we have opposite and adjacent as our 2 known sides, I'm using the tan relationship. That's the only one I can use to successfully work out this angle theta. I can substitute in the value for each of the opposite and the adjacent lengths there, and I've done that, 9 and 12. And I can simplify it down, so 9 and 12 makes 0.75, and so I have a statement there, tan theta equals 0.75. Like we saw before, we need to use the inverse of tan, so we set up a statement now that says theta equals the inverse of tan of that ratio, which came out to be 0.75. That's what we put in the calculator, and we'll find that theta equals 36.87 degrees when it's rounded to 2 decimal places.